Hello, good evening. Can you hear me?
Yes, sir, I can hear you.
Okay, okay. I'll start in few minutes. Okay. So yeah. Good evening. So today we'll have tutorial for week 9. This is Rahuldev Ghorai from ISA Thiruvananthapuram. So that for today's topic for the problem answer question and answer are these. I mean vector spaces and mainly we'll do some we'll learn about some spanning set based on dimension and rank of a matrix. Already although we have done, we can do little bit because in the last class we have done this rank of a matrix, and also will have like linear transformation question answer from linear transformations. Okay, so the what is spanning set? If I start with the spanning set, so first of all, I hope you all know the definition of vector space, right? I think who is here, like you were only here, right? I forgot the name. You know the definition of the vector space, right?
Yes, right.
Or I mean I have to again teach that. I mean it's not possible yet now to teach. I mean if you have vector space, mainly vector space, when we say vector space, that has to be over a field or over yeah, over a field, like over mainly you can for now, like in your in this course will be vector space will be always over set of real numbers. I mean, if you have, I mean, like you know, the R2 is a vector space. R2 is a vector space over R, right? Now in R2, you take one element, let's say 1, 0. You have one element in R2, right? Which is in R2. So you have 1, 0, right? This is the point 1, 0. So now if 1, 0 is in R2 and R2 is a vector space, what can you say about, like uh, what more you can say, like what the other elements are in R2? So can you say any like first of all, you are considering only one point, right? 1, 0. So if you you know if one point is there, If 2 points were there, then addition of those 2 points would have been there. But here, what you have only 1 point. But what you know as R2 is a vector space, any C belongs to R2. If you take, from a real number set, then C times 1 0 also should be in R2, right? Because R2 is a vector space. And this is nothing but a spanning set. So, spanning set, the definition is like spanning set of, 1 0, you like you understand by this example, spanning set of 1 0, which is a set, right? It's a set of 1 point. So that is nothing but C times 1 0, where C belongs to real number, right? So can you say what is this set mainly? What is the spanning set? What will be the spanning set of 1 0 then? Geometrically, what is the spanning set, or what is the spanning set? What will give you this spanning set? What is that? Nothing but that is nothing but this whole line, right? That is uh, x-axis. So you can show that this x-axis, we have already shown this x-axis. What is the x-axis mean? It is x0. X-axis is nothing but this, right? Such that x belongs to R. This is a subset of R2, and that you have already, all of you know, that is a subspace of R2, and that is also a spanning set of a set. That set is a singleton set 1 0, right? So what I am telling, that the spanning set of a set will be a vector space, and one can prove that that is a smallest vector space containing that set. Okay, and that will be also a vector subspace. Vector subspace. So if you take, let's say, if you take one point in R2, 1 in R2. So what will be the spanning set of 1 1? Can you tell me quickly? What will be the spanning set of 1 1?
Positive first quadrant.
Sorry,
First quadrant.
first coordinate. No, no, right? How? So what is the spanning set? Spanning set is nothing but a set which, if you have one element, you get another elements. You construct a vector space out of that point or points. If there were 2 points, you could add and get something like that. But if you have if you have only 1 point, in that case, spanning set will be just multiplied by a real number. You have, if you have S is equal to V1, V2 up to Vn vectors, and V i's, V1, V2 are uh, element of a vector space V, then spanning set of S, we name it as LS, is equal to C1 V1 plus C2 V2 plus plus Cn Vn, such that where Ci's are belongs to set of real numbers. So when we talk about L of 1 1, spanning set of 1 1, that will be then nothing but this. See, L of 1 1 means 1 1 is V1. Let's say V1 is 1 1. So that will be C1, or let's say C1 is the C1 times V1 only, where C1 belongs to R, right? So that implies C1 times 1 1, where C1 belongs to R. Any real number you take, you multiply by to 1 1, then it will be the spanning set of 1 1. So 1 1, if you multiply by 3, it will be 3 3. You multiply by half, it will be half, like that. It will keep on going. So if you start with 1 1, if you start with 1 1, all the elements through the like line, and if you join line between line with this 0 0 and 1 1, let's say this is 1 1 and this is 0 0, then any line which passes through 0 0 0 and 1 1 will be the spanning set of 1 1 point.
Okay, okay,
And
sir. Thank you.
yes, and that you can prove that that is a vector subspace of R2 also. So, like whatever I was telling here, that will nothing but implies that if you have a spanning set that is a subspace, and that is the smallest subspace containing that set. That's a very big statement. Spanning set. So that is what you need to know. Spanning set is the smallest subspace containing the set. That's what I mean. Like I wanted to give you. Okay. So let's say you have. So now tell me what will be the spanning set of 1 0 and 0 1. These are two vectors in. I mean they are subset of R two. This set is a subset of R two, and each of the elements are in R two. So what will be the spanning set of? Let's say this is. I'm telling this is S. What is L of S?
Well, office can be written as a linear combination of these two sets, C1
Exactly, linear
into 1
but and more.
plus
I want to
C2.
know more. Like, what will be the exactly the set? You tell me. This is C. S is subset of R two, right? So
Yeah.
L of S will be somewhere in R two, right? Maximum. It cannot go beyond
Yes,
S2,
sir.
S2, R2. But what is it is exactly? It can be like only first quadrant. It can be second quadrant. It can be a line. It can be like that. So, but what is exactly this? Can you tell me exactly what is LS? See,
Yeah,
yeah.
it is the x-axis and y-axis.
No, no, no. See, that's a mistake. So what we will do when we had only 1 0, then the thing is C times 1 0, whatever it gives, that is the spanning set. When you have 0 1, then you multiply another another point, another scalar d, some d, which C and D are real numbers, but is both will be in the spanning set, but the addition of these two will be also in the spanning set, right? So when you add these two, what will happen? C times 1 0 plus D times 0 1 will be nothing but C comma D, where CD belongs to set of set of real numbers, and that is nothing but any point in R2. So what I am saying that L of S will be R2. L of S will be R2 because you give me any point in R2. Let's say you gave me x naught, y naught. I could write x naught, y naught as linear combination of 1 0 and 0 1. Right? Right? This is nothing but. So that implies this x naught, y naught, which was in R2, they belongs to L of S. And L of S is always subset of R2, and this implies L of R2 is subset of LS. I mean, thus in this case, if S is equal to 1 0 comma 0 1, then L of S is nothing but whole R2. What does that imply? So any R2. in in R2, if you have any point, you can write linear combination of these two vectors. It's a very big statement. I mean, very good result, right? So you don't need to know any other points. Only these 2 points are enough to know about R2. And R2 is a vector space, and when you can generate a vector space by these 2 points, and if these 2 points are linearly independent, if you can prove somehow, that will be coming later, then you can say that these are the only two, no, not these are the only two, these are the points. So you can say that that set S is a basis of R. There can be many bases, but what I am telling, the basis has to be a set which is linearly independent and also subspace, also generating set. I mean, also linear span of that set, so has to be the whole vector space. So in this case, this S will be a linearly independent set also, and also it is a generating set. I mean, it's the linear span of this set will be whole R2. So we can say that this is a basis. So what I'm going to tell now is basis of a vector space. Basis of a vector space is a set S such that L of S is equal to V and S is linearly independent. So what do you mean by linearly independent? So linearly independent, yesterday also I have said, if it is not linearly dependent. So what do you mean by linearly dependent? So if you have two vectors, then if you somehow can get from another vector, or if you have three vectors, if you can get one vector, any of them you can get from another two vector, then that is linearly dependent. Otherwise, it is linearly independent. Mathematically, what we say, you say V1, V2 up to Vn are linearly independent if C1 V1 plus C2 V2 plus Cn Vn is equal to 0 for all this. This should imply, if this should imply C1 is equal to C2 is equal to Cn is equal to 0. So can you now check that 1 0 and 1 minus 1 are linearly independent, whether they are linearly independent or not. Also check that 1 0 and 0 1 are they linearly independent. So you can check that this is both of them are linearly independent and they span R2. So what we can say that these are the two are bases also. They will form a basis, and R2 has dimension 2 as basis has two elements. Okay. So similarly, you can say that R3 has dimension 3 and all these things. So do you understand up to this basis, dimension and spanning set? I mean, I gave you very like easy example to understand so that you can understand. So yeah, I mean, do you understand this?
Sir, I did not understand here. How can we say linearly independent? They are not linearly independent. Linearly, yeah, yeah,
Linearly?
yeah, yeah.
Tell.
Yeah, they are linearly independent. How to
Then
check that? Linearly independent or not?
yeah, okay. So let us take that. So C1 times for linearly independent, what you do? Take two scalars and multiply and then add, right? And make it, let's
Yes.
say,
Yes.
0. So can we say that C1 and C2 are both 0? So what will happen from here? Tell me now. C1 comma 0,
One is minus C2 equals to 0.
C2 minus C2, right? tell me whether I am doing correctly. Okay, minus C2
Yes, sir.
is has to
C2
be
is
0
0.
0, but
Yes.
that implies
Both C1 and
C1
C2 are 0.
C2 is equal to 0 and minus C2 is equal to 0. So C2 is equal to 0 and C1 equal to 0. You are getting right.
Yes, sir. Yes.
So that is the meaning of linearly independence. I have already discussed here. That is the linearly
Yes.
independence.
Yes, sir. Understood.
Let me write in. Okay.
Okay, sir.
Yeah. So that's how
Understood.
you can prove that something is linearly independent. And when you have linearly independency, and then you can show that this set is when it is linearly independent, then you will have, and if it is a spanning set also, then it will be basis. And once you know basis, many things you can know, but like not many things. For a finite dimensional vector space, everything is possible to know about that space if you know the basis, right? Because if you know the basis, you know all the elements. It will be some combination of that set. Okay. So
Okay.
yeah, I mean, let's say in R2, I mean, sorry, in R2, you have let's say 1 1 1 minus 1. Okay, so are they linearly independent or dependent? Can you say anything about this?
Yeah, just a minute. I will do it. We have to take a linear combination with all the three elements, like C1,
Yes.
C2 equals to 0, and C1 minus C2 plus C3 equals to 0.
Yes.
So from these two, we can eliminate C2. Then we'll get C1. Then C1. I think linearly independent, sir.
Sorry.
Linearly dependent, sir.
Why?
Because we require three unknown variables, okay,
Yes.
but we are having only two equations. It's
So it
difficult
will
to
have
find,
infinitely many solutions. Are you telling?
sir.
So it will have
Please come
infinitely
again.
many solutions, right?
Yes, sir. Infinitely many solutions.
Because if you take C3 is equal to 0, then C1 plus C2 is equal to 0 and C1 minus C2 is equal to 0. From that you can get C1 and C2 both are 0. But if you take C3 is equal to 1, you will get this will be negative and this is 0. So from there what you will get, C1 will be minus half and C2 also will be C2 will be half, right? So one solution will be there. This what I am telling. This minus half times 1 1 plus half times 1 minus 1 plus
Plus
1 times
one times
0 1 will be 0 0, but none of them are non. I mean, at least one of them is non-zero. Also, it is fine. But here we see uh, none of them are 0, right? So this
yes,
set is linearly dependent. So this is linearly dependent, right? So this we can think in another way. This is like first vector is 1 1, right? Vector we always write like this in the matrix case. So this is second vector is 1 minus 1. Third vector is 0 1. And if I write in terms of augmented matrix, that will be 0 0, right? Do you understand this?
yes, sir. Yes, sir. Understood.
This is augmented matrix, right? So
Yes,
now,
augmented matrix.
if you try to get row reduced echelon form, what you will see? We want to find row reduced echelon form of this, and we can know that if this matrix, like this augmented matrix and the matrix, same matrix, the augmented matrix and this matrix has the same rank, then we can say that it will have infinitely many solution or one solution. Solution will exist. When you say solution exists, then first you need to know that what are the solution, right? If solution does not exist, so it has to be then 0 0 0. Solution does not exist means 0 0 will be of course a solution of this matrix, right? This ax equal to 0 will have always x equal to 0 is a solution, right? But other than that, no other solution exists. Okay, so like that we'll see how. So if you take r2 minus r1, then it will be 1 1 0 0 0 minus 2 1 0, right? So now it is in row echelon form, right? The dimension of sorry, this is yeah, 1 minus 1 is 0 minus 1 0. So if you take the matrix, whole matrix A, and this matrix A augmented B, I mean, if the B is a 0 0 matrix, then both will have rank 2, right?
Yes, sir.
So they are having same rank. I mean, when they have same rank, so the solution exists, and we can say the solution exists, right? The when existence of solution is there, and you can anyway leave this one. So you can show from here that the minus of half and one are the solution of this one solution of this matrix. Okay, so it's fine, right? This up to this is fine, right? This matrix representation we will do later, but up to this is fine, right? Okay. Hello.
Yes, sir. Up to this, okay, sir.
Okay. Okay. So one can show that like many example with, like, let's say the set of solutions of ax plus by plus cz is equal to 0 for a b c not equal to 0 is a vector subspace of R3. So this is nothing but a plane passing through the origin. Okay, so you can show that this is very easy to, like, it is a, like, in the subspace. I wanted to give an example, and yeah. So linearly independent set also you understood. Now it is you know the spanning set, basis, everything, everything you understand. So now we'll,
Yes, sir.
yes, now we will solve some questions based on this. Okay. After that, again, maybe we can do some theory again. So here is the question from your assignment. It is telling that 1 3 minus 4 2 comma 2 2 minus 4 0 1 minus 3 2 minus 4 minus 1 0 1 0. So if you this is a set S, this set is S. This asking that, see, it has 4 elements, but the question is whether this will span whole R4. So L of S is equal to R4, is this the question? I mean, it spans R4, or in other word, R4 is, I mean, yeah, R4 is generated by S, or whether S span, whether S span R4. That's the question. So for this question, you can approach by the matrix argument. So, what is the meaning that this will span R4? So, answer will be like this. So, if it span R4, I mean, how it will look like? If you take any V1, V2, V3, V4, R2, you can write V1, V2, V3, V4 as linear combination of V1, sorry, linear combination of limit C1 times 1, 3, 4, minus 4, 2 plus C2 times the other vector plus C3 times that vector plus C4 times another vector, right? What is the meaning of this? Whether it is asking that whether this system has solution for any V1, V2, V3, V4. Okay. So for that, how you can write this system? This system you can write 1, 3, minus 4, 2, 2, 2. I mean, it was 2, 2, minus 4, 0, like that. All these are vector minus 4, 0, 1, minus 3, 2, minus 4, minus 1, 0, 1, 0, and then the augmented matrix will have V1, V2, V3, V4. So now we'll do some operation, like we'll to find out that whether this system is having a solution. Okay, that we have seen already, right? We have done all these type of examples. So we'll do something like this: R2 my R2 minus 3, R1, and R3 also will do R3 plus 4, R1, and R4 minus 2, R1. Then it will change to 1 to 1 minus 1 phi 1, it will be as it is. R3, R2 minus 3, R1 will be, this will be 0. So minus 4 minus 6 plus 3, V2 minus 3, V1. Now it will be 0, 4, 6, minus 3, V3 plus 4, V1. Okay, so now it will be 0, minus 4, I guess. Yeah, minus 6, 2, V4 minus 2, V1. This is the matrix. Still, it is not in the row echelon form. So then, so we don't know whether solution exists or not, or what are the solutions. So we'll do one more operation. See, here it is already the pivotal element is there. So here it has to be pivotal element. So other two element has to be 0, 0, right? So that's why what we will do is R4, sorry, R3 plus R2 and R4 minus R2. That will give you 1, 0, 0, 0, 2 minus 4, 0, 0, 1 minus 6, 0, 0, minus 1, 3, 0, minus 1, and other things will have V1, V2 minus 3, V1, V1 plus V2 plus V3, V1 minus V2 plus V4. So can you now tell me for any V1, V2, this system is consistent or not? If it is inconsistent, then you are done, right? You can say that for that value of V1, V2, V3, V4, for all the values, you will not have any solution of this system. When you say that you don't have any solution to this system, we can say that uh, this one will not exist. I mean, you cannot always write as a linear combination, right?
Yes.
So if you take V1 is equal to 1, V2 is equal to 0, V3 is equal to 0, V4 is equal to also 0. Okay, if you take this, what will happen? Your dimension of, I mean, if you take this, what will happen? V1 plus V2 plus V3 will be 1, which I want, which is not equal to 0. But in this column, you will see all other elements are 0. So if we take like that, so what will happen? This system will become 1 0 0, 2 minus 4 0 0. So 1 minus 6 0 0, 1 minus 1 3 0 minus 1. See, V1 is equal to 1. V2 minus 3 V1 will give you minus 3. This will be 1. This will be V1 minus V2 is, this will be also 1. So then this is the matrix A and this is the matrix A augmented B. Rank of, what is the rank of A?
A
What's the
is
rank of
3,
A? And what is the rank of
3,
A augmented B?
4.
A augmented B is 4, right?
Yes. Rank of A is 3.
Ah, exactly. Rank of A is 3. So 3 is not equal to 4. So system is inconsistent. So will not have no solution. So what you can say that from here, what you can say that 1000 point, it the set, this set, we started with this set, right? This set cannot span, it can't span 1000. When it can't span R4, and the linear combination of any, if you take a linear combination of this thing, it won't be belongs to in the L of S, that I mean whatever the linear combination you take, you won't get 1000 point.
But for it may exist for other values, no, sir?
Other values of what? Other vectors, other set, you can say.
Yeah. For example, we took V1 is 1, V2, V3 values, V4
That
values
might
are
happen.
0.
That might happen. That might happen. But at least if you can prove what for one element, you are done, because the question is
If it is
asking.
failing, then it is total fails.
Sorry.
If it is failing for a contradiction part, then it fails for all the total set.
Yeah, I mean, at least one point is there which is not in LS, right? 1000 one triple zero. This is not in L of S. That you understand, right?
Yes, sir.
When that is in that is not in the linear combination of this set, but that is in R4. That is one element in R4 also. So it gives you that this two set cannot be equal. If it is equal, all of the element has to be there are in R4, right? All the element in LS has to be in R4, and all the element in R4 should be in LS. But we are getting one point which is not in L of S but in R2. So that's why LS will not cannot be whole R4.
Okay, sir. Okay, sir. Understood, sir.
Yeah. So yeah. So I told you the basis, right? I mean, whether you can uh, I mean, write whether you can find a basis. I mean, in R3, so it is some questions are there from your assignment. Can you prove that this whether this is basis or not? Is S1 basis? Is S1 a basis for R3? Can you try it? I'll give 5 minutes maybe maximum. Can you check it quickly?
Yes, sir. I'm checking, sir.
Okay.
Yes, sir. For any value of V1, V2, V3, the system is having a consistency.
Yeah. What? Sorry. Consistent with.
For any values of V1, V2, V3, the system is consistent.
Oh, you are getting that. Okay, great. Then it will be. Then what
It
does that mean?
L of S is equals to R2.
L of S1 is R3. Okay, that we got. I assume that it is coming. So L of S1 is you got R3. So I will just check the answer whether that is there. Yeah, L of S1 will be R3. But is it a basis? Now next question. Another one you have to find it, right? One thing you got correct. Second one you have to find out whether linearly independent. Can you do that?
Yeah, a shortcut method to check whether it is linearly independent or not. We can take the determinant of this 3 by 3 matrix equals to 0 dependent, if not equals to 0 independent. Am I correct, sir?
Equal to 0 mean?
Its determinant of this matrix is 0.
Yes.
Okay, then linearly independent. If it is not equals to 0, linearly independent.
That you can do. That is easy. That is also you can do. We can also use this 1 0 minus 1 2 5 1 0 minus 4
Yes,
3 and take 0 0 0 and now check that whether this system is consistent or inconsistent. If it is consistent, it will have only unique solution and that has to be 0 0 0. So then you can say
it
that
is
it is
non-zero, sir.
that also you
It is
can do
not equals to 0, so
in any of
linearly
the
independent. It is not equals to 0, so linearly independent.
determinants not equal to 0 you are getting.
Yes, sir. Not equals to 0. We are getting the determinant
Okay.
is
Also, in this way, how we will do R3, sorry, R3 plus R1, then it will be 1 0 0. I mean 2 5. It will be
3.
3 0 minus 4 3 0 0 0. And again, if you take this quantity minus 0, it will be you can make it means R3 minus 3 over 5 is R1, sorry, R2, that will be 1 0 2 0 0 5 minus 4. This will be 0 and this will be 3 plus 12 over 5, which is not equal to 0, and then 0 0. So if you take yeah, I mean it will be it is consistent, right? This system is consistent because rank of A and rank of A augmented B are equal, so they are consistent and it will have unique solution. When you have unique solution of Ax equal to 0, you always Ax equal to has a solution like x equal to 0. So unique solution means it is the only solution, and that implies this. You take c1 times this vector plus c times one another vector plus c3 times the another one vector is equal to 0, 0, 0. Then only solution is c1 equal to c2 equal to c3 equal to 0, right? You understand
Okay,
this?
sir. Yes, yes.
Yeah. Okay. So anyway, you can understand the other words. Okay. So anyway, it's fine. See, why determinant will not be a good choice if you have a different order. I mean, it's a 3 by 3 matrix or 2 by 3 matrix. Then it is difficult, right? You cannot find out the determinant in that case. So yeah, that's why you can do in this way in that case. So can this one has 4 minus 6 1 5 8 2 1 1. Yeah, I mean this is the example where you cannot tell using the determinant. This is suppose say S2 basis for R3. If it is a basis, then first of all, like S3 R3 has dimension 3. All of us know, right? R3 has dimension 3, and then the basis must have element whatever the basis you have. Basis set can be infinitely many basis set you have, but the element number of elements should be 3. So this set has 4 elements, more than 3, so it cannot be basis. That's how also you can give the argument, right? You can give argument
Can you
like this,
repeat
or
again?
you can do in this way also. But the argument here it will be basis should have 3 elements because the dimension of R3 is 3. So any basis consist 3 elements, not
Can
more
you
than
repeat
3
it
elements,
again?
or not less
Sir,
than 3. Yes.
can you repeat it again? Statement.
So any basis of R3
Should have three.
should consist 3 elements because dimension of R3 is 3.
Yes.
Yeah,
Yes, sir.
right? Yeah. So but S2 has 4 elements,
Okay.
so it cannot be basis. That's it. That's a very simple way you can answer to the point answer, and it's a very correct answer also. So if you take so similarly, if you take in R2, the dimension of R2 is 2. Mean the basis element, whatever the basis set you have, that should have only 2 elements, not more than 2. So if you now that's why if you take 1 0 0 1 and any other element, let's say uh,
Zero.
2 2 or 0 2, whatever the element, this won't be a is not basis. You can say not basis. No need to
For
check. Not
example, sir,
not
sir,
basis.
excuse me.
Huh?
Sorry for the disturbance. If I am taking the third element is zero zero, then
Third element is
instead
0
of
0.
three
Then
comma
it
two.
that's yeah, that you cannot take. I mean, non-zero element you have to take. Yeah, that's a good question.
Okay.
Yeah, I mean
Okay.
non-zero because 0 0 always. Yeah. Wait 1 minute. So if you have 0 0 element also, so that will be also linear combination of this 1 0 and 0 1. But mm, see, okay, let's do it. When you take 0 0 element, then anyway you can base it will be basis. I mean, it will be generating set. That is not a problem. but whether it will be linearly independent. Yeah, if you take 0, 0 also, that will be linearly dependent. Why? 1, 0,
No, sir.
0, 0, that set is linearly dependent. Linearly dependent. But for basis, it has to be linearly independent, right?
Okay, okay, okay.
Why linearly dependent? So here I am giving you a general statement. Any set which contains 0, 0 will be linearly dependent. Why? See, this set you can write as 0 times 1, 0 plus
Plus
0,
series
1
of
plus
plus
1 times 0, 0 will be
it
also
is the
0, 0,
series.
right?
Yes, sir.
Where 1 is not equal to 0. So what does that imply? This implies that you have a non-zero solution of that system, or this system is linearly dependent. So not necessary that all the coefficient will be 0, then only the sum will be 0, but there exists one combination, means 0 times 1, 0 plus 0 times 1, 0, 0 times 0, 1, and 1 times 0, 0 will be also 0, 0, right? So this is linearly divided. But anyway, in any case, you will get more than 2 element, it will be linearly dependent. Okay,
Okay, sir.
and also it won't be basis. Yeah, if you take a set of all polynomials, let's say you have a set of all polynomials. No, let's say you have polynomial p, for set of polynomial which has degree less than equal to 3. What type of polynomial that will be? A naught plus a1x plus a2x square plus a3 x cube, such that a1, a0, a1, a3, they are in real number, set of all real numbers. So dimension of P will be what? So first of all, can you give me? Can you first of all prove P is a vector space? Right? It is okay to prove. Right? It will be easy to prove. P is a vector space over set of real numbers R. That you can prove. It is easy. Take two elements, add. You will see again. It will be in P, and all these things it will be. Okay. So
Okay.
this P is a vector space over R. We can say that. But I mean, the question is, what is the dimension of P? First of all, can you check the hint? Is can you check 1x, x square, x cube is linearly independent, or
How to check, sir? Whenever we are having some things like earlier, we can check whether it is linearly independent or not. But now here,
sorry, can you repeat?
earlier we are having like elements, but here unknown variable are there. Then how to
Yeah,
identify
that's also you
linearly
have
independent?
to. So what anyway? What you have to get, like what you have to do? This c1 times 1 plus c2 times x plus c3 times x square plus c4 times x cube, right? That has to be 0. I mean that is 0. Then what are the solution of this system? That extreme maximum you have to find. That is what you have to find, right?
Yes, sir.
So if this is 0, then what are the cases? For any x it is 0. For all x in R, right? So when x equal to 0 also it has to be true. So C1, then
No.
that implies C1 has to be
Equals to
0. Again you take some x is equal to let's say x equal to 1, then you will get C2 plus C3 plus C4 is equal to 0. X equal to, let's take -1. We will have minus C2 plus C3 minus C4 is equal to 0. From here you will get 2C3 is equal to
Even also
0.
will be even also will be included in both the cases, sir.
Sorry?
The first term also includes because C1 is a coefficient of 1. The
Huh?
first term also will include when x equals to
When?
1 and x equals to
When
when
x
x
equal to
equals to 1
1.
and minus
But
1.
when x equal to 1, C1 is equal to 1. C1 will be there. But C1 is already 0. We have seen from x equal to 0. When
Okay,
x equal
okay,
to, yeah,
okay,
all the cases we are considering, right? So C1 has to be 0. I
okay.
mean, anyway, when a polynomial is equal to 0, then all the coefficient has to be 0. That's the thing. That's also you know, right?
But whenever we are taking x is a something x is 0, then we are getting c1 is 0. It cannot be used when x equals to 1, na, sir.
No, what I'm telling that I start with this quantity which is this is equal to 0 for all x equal to 0. I have started, right? If it is for all x equal to 0, when x equal to 0 also it has to be satisfied.
Yeah, we are getting c1 is 0 for x
Then
equals
C1
to
has to
0.
be 0. It is independent of,
Yes, sir.
like, whatever x you take, it has to be 0 then, right? Because the combination from combination what you're getting, if it is x equal to 0, then this thing is also 0. I mean, our in our case, this another function you can take is c2x plus c3x square. Sorry, c naught, c1, c2, c1, c3 x cube. But what it is telling that f of x is 0, f of
When
x is
x
0,
is
f of x is 0. That implies f of 0 also has to be 0, right?
okay,
That implies c0 has to be 0.
0.
So hence c0 is equal to 0. Function is now again changed to c1x plus c2x square plus c3x. It's not it. Do you understand
Okay,
now?
okay. The function is updating.
Yeah, now
Means
function updated. Function is now this. So when now you have f1 is equal to 0, f1 is equal to 0 implies c1 plus c2 plus c3 is equal to 0. F of minus 1 is equal to 0 implies minus c1 plus c2 minus c3 is equal to 0. That implies again c2 is equal to 0. So c2, if you add these two, it will be c2 equal to 0. That's implies c2 is equal to 0. Then what you get, your function now become uh, c1x plus c3x cube. Okay, right?
yes, sir.
So now how do you show that c1 and c3 are 0? That's one question. For this, take f of 1 is equal to 0 implies, because f of x is equal to 0 for all x, it has to be true. So f of 1 is equal to 0 implies c1 plus c3 is equal to 0. F of uh, 2
Minus
is
1.
equal to 0. Yeah, 2 is equal to 0 implies 2c1 plus 8c3 is equal to 0. So if you subtract from here to here by 2, multiply by 2 and subtract, then it will be 6c3 is equal to 0 implies c3 is equal to 0. That implies c1 also has to be 0. That's how f is nothing but 0. When f is nothing but 0, sorry, f is nothing but 0 means c1 is equal to 0, c2 is equal to 0, c3 is equal to 0, c4 is equal to 0. C not equal to also 0 as well. Do you understand this?
Yes, sir.
Yeah, I mean, when polynomial is 0, the all the coefficient will be 0, that you can assume in real numbers. Okay? So
Yeah,
that's why
linearly
linearly independent. And now,
independent.
now can you show that this is spanning set of spanning set? I mean, span of this will give you the whole P.
Spanner?
Span of this set 1x, x square and x cube.
Is 3, sir.
Sorry,
R cube. R cube. R cube.
what is R2?
Sorry, sir.
What you are telling?
Uh, uh, Linear span of this set is R cube.
R2.
R cube. R cube. R power 3.
But it is not a subset of R power 3 also, right? When you have 1x, x square and x cube, 1x, x square and x cube, you take linear combination of this, it will give you 1 plus x or 1 plus x square or 2 plus x cube, or are these in R3?
Yeah,
No,
no, sir. No.
they are not element of R3. So that element of P, we call it P3. P3 over R or P3 means this P3 you call it a P3 set of all elements. I have already written that a1x plus a2x square plus a3x cube. Mean they are polynomial, so they has to be subset of polynomial. If it's span, it will give some subspace of polynomial. So that is nothing but if you have 1x, x square and x cube, from the construction of P3 itself, what you can say that this will, the linear combination of this will be nothing but this P3, right? Because the definition of linear combination says that you multiply by multiply by scalars and then add it, that will be the linear set. So here also if you see the construction of P3, that is nothing but this linear combination, right?
Okay, sir. Yes.
So this is linear combination of this set, and this is also linearly independent. So this has to be the basis. And you see, P3 was polynomial set of all polynomial uh, with degree less than equal to 3, but dimension of P3. What is the dimension of P3?
It will be 3, sir.
No, how? What is
Because of
the
degree less than or equals to 3.
huh?
Highest power of x is 3. Highest power of x is 3.
That does not even, but here we are doing a vector space as a vector space. That set is a vector space, and the
Dimension is 3.
dimension is the number of element in basis set.
4, sir. 4.
So dimension will be 4. So always it does not depend on how you are defining the set. It depends on the number of basis element. So
Number
that's
of
why
elements.
exactly number of basis element in the set. So that's why I gave you this example that here it is, although it looks like P3, so dimension will be 3, but no, dimension of P3 is 4. Similarly, you can prove that I mean, okay, this will be easy. I mean, 1 0, sorry, not 1 0. I mean, any matrix A B C D, this type of set of all matrix, this will have dimension 4. That is easy anyway.
Yes.
That is, I mean, it is like R4. Anyway, so now we come to something called rank nullity theorem, where you can prove that where if you know a rank of a matrix plus nullity of a matrix is equal to if the matrix is of order 5, order of matrix for a for a square matrix. Okay, you can do it for a square matrix, and what you can show that if you can find out rank and you know the order of matrix will be given, so let's say 5 by 5 matrix is there, if the rank is 3, then you can say the nullity of A will be 5 minus 3, that is equal to 2. So there are some examples of there. So if you want to find out nullity, then you can do like this way. So let's say you want to find out the nullity of this matrix. Can you find out the rank and then you find nullity? For two, it will be good for you. These are the things you can get in your exam also. Can you mute and do it? After that, you tell me.
Sir?
Yeah, you do it and tell me. Huh? Try.
Yeah, we can say here first column and second column same, both are. That means similar.
Yes. So,
So
so what it will
rank
mean?
may be greater than or equal to.
Yeah, from there you can say that rank cannot be 5, but you cannot tell anything more.
Actually, order is 4 by 5. So we can take, we can call it as a 4 maximum rank is 4.
Maximum is 4, but you need to know whole rank, right? Full, what is the rank? It can be then 1, 2, 3, 4. Maximum it can be 4, 1, 2, 3, 4. Anything can be, right?
Yes.
So what will be the answer? Rank, what is the rank? I
Yeah.
have to do the row
2.
echelon form, right? To do a row echelon form of this matrix, this matrix, and then you can show that this matrix will have rank. You have to find the row echelon form, okay? So I'm not telling here. Rank of A will be 3, and then nullity of A will be 5 minus 3 is equal to 2. Okay, check it. Anyway, it's rank, finding rank already I have done in the last class.
But as you mentioned, sir,
Yes,
this is 4 by 5 matrix, na, sir. So
yes.
how to take a order of A is 4 or 5?
No. In that case, you take number of columns mainly. Number of columns.
Okay, maximum number of it may be rows or columns, whatever it may be.
Columns. No columns. Yeah.
Okay.
So how it will you can understand? If you have
Yes.
A, what is A? A is 5 by 4 matrix, right? I mean, sorry, 4 by 5 matrix, right? Is it correct? A is 4 by 5 matrix. Hello.
Yes, sir. Yes, sir. 4 by 5 matrix.
4 by 5 matrix. Now, if you take X, which is mean R5, you define a map X goes to AX. From where to where it will be? R5 to R4, right? If you multiply A with X, what will happen? X is 5 by 1 matrix. 5 by 1 matrix is a vector. And A is 4 by 5 matrix. Then this, what will this imply? This A times X will be in R4. And what will happen? This rank nullity theorem is nothing but it says that if you have a if you have a transformation like this, I mean T, let's say T is from R5 to R4, and T of X is nothing but AX, and then it will be a linear transformation, which I'll just tell you what is linear transformation. Then dimension of, sorry, your, I mean this uh, R5, that this dimension of, can you mute for some time? I mean sometime mute. It's too much voice.
Dimension of
Can you mute? yourself for some time. Yeah, yeah, thank you, thank you.
Okay.
So, yeah, so what I'm telling, this dimension of R5, that is the exactly wrong nullity, is nothing but dimension of kernel of T plus dimension of uh, image of T. From there only it is coming, this dimension of R5 is 5. 5 will be dimension of kernel of T means the nullity of A plus dimension of uh, rank of A. Okay, so mainly that was your, that's why it has to be the column. Otherwise, it has to be column, not the maximum of, okay? It has to be column of the matrix. We'll see in the linear transformation. So linear transformation is nothing but a function mapping from a vector space to another vector space, which is linear in the sense that if you, it preserves the linear, it preserves the linearity, preserves linearity. Linear transformation is a mapping from vector space to vector space which preserves linearity. Means if you take t times v1 plus v2, it should be tv1 plus tv2, and if you take c times v, it should be c times t of v, because where c is from the real number set, v is from the vector space v. Okay. Anyway, the what I wanted to say that this has to be the column. Okay. Do you understand this? Tell me just yes or no.
Yes, sir. Yes, sir.
Okay.
Understood, sir.
Okay. So it has to be column. Now we'll move to one another question. So can you now? I have said that what is linear transformation. Do you understand linear transformation?
Yes, sir.
When I say M2 by 3, and this is the set of all matrices of 2 by 3. My order 2 by 3, I mean, yeah, of order 2 by 3, 2M2 by 3 are, and I denote T of A by A transpose. Can you prove that this is a linear transformation?
No, sir.
Try.
It is M. It will become M3 by 2 now, sir.
No. 2. Sorry. 3 by 2. Yeah, this one is 3 by 2. Yeah, it's true, true. Thank you. Yeah. You try now, try whether it is a linear transformation or not.
Yeah, it is a linear transformation, sir.
Why?
Using the general form of transpose of the matrix form, we are going.
If it,
Is there any
I don't understand. What are you doing?
simply using the matrix transpose of the matrix form? That type of definition we are able to say. We can say yes.
I mean, T of A plus B has to be TA plus TB, right? Have you checked those things? That's what I'm asking. Right? For linear transformation, this T of A plus B is nothing but A plus B whole transpose. But the matrix rule says that it has to be A transpose plus
A
B transpose.
transpose plus B transpose, it is T of A plus T of B.
Yeah. So similarly, T of some C times A has to be CA whole transpose. That implies and matrix multiplication says that matrix transpose rule says that this has to be like this. So it is a linear transformation. Okay.
If these two
So
conditions are able to solve, then we can say directly linear transformation, sir.
yeah, these two are solved. Then we can say that linear transform. Also, T of zero usually prove that T of zero is to be zero. Sometime. Okay. Otherwise, these
Okay.
two are main.
Okay, sir.
Yeah.
Thank you.
So So t of, let's say t of x is equal to x plus 1, and t is from set of real number to set of real number. Can you prove that this is a linear transformation?
No, sir. It is not linear transformation because T
Why?
of A plus B can't be T of A plus T of B form.
Yeah, that's like all the none of the properties will be satisfied, right? None of the properties will be satisfied. So no, not a linear transformation. Okay, that's good. I mean, even t of 0 is not equal to 0, so that should be the thing. Okay. Okay, so another question is, let's say t from R2 R2 t of x is equal to x comma x. Will this be a linear transformation? Also another t which is from R2 to R2, let's say t of xy goes to yx. Let's say I'm finding giving like this
First
t3
one is
from
linear transformation. T1 is linear transformation.
first one is linear transformation.
Yes, sir. Linear transformation.
Why? All the satisfy all the property, yeah, it will be satisfied linear transformation, correct. Then
Second one is also linear transformation T2.
yeah, that's correct.
T3 is also linear transformation, sir.
No, it's not true. Check it. Check once.
Yes, sir. Wait. I'm getting linear transformation only, sir. T3 also.
Hello.
Hello, sir. I'm getting T3 also linear transformation, sir.
No. How you are getting?
I took P of x1 comma y1 equals to x1 minus y1 comma 0. P of x2 comma y2 equals to x2 minus y2 comma 0.
Yes.
Then P of x1 plus x1 comma y1 plus x2 comma y2. It's nothing but P of x1 plus x2 comma y1 comma y1 plus y2, I can write.
Yes, that's not a problem. Then
Uh, then I am getting the right hand side is x1 plus x2 minus of y1 plus y2. Nothing but x1 plus x2 minus y1 minus y2 comma 0.
okay.
Then I split it as x1 minus y1 comma 0 plus x2 minus y2 equals to 0 form. Then the first one is t of x1 y1 plus the second term is t of x2 y2. It's satisfying the condition.
Yeah.
Next, same thing. If I go for t of cx1 comma cy2, then I am getting cx1 minus cy1 comma 0, taking c common, then I am getting c into t of x1 comma y1.
Yeah, that two properties are fine. That, but did you see what I wrote in this?
Yeah, okay, okay.
Yeah,
Yeah,
so that's
here,
why I wrote
controversy
the
parts.
end. So T of
Always we
0
have
has
to
to be
check
also
about.
0 value.
Yeah, yes, sir.
That's the
Always we have to
one.
check about the controversy parts.
Yeah, 0
Right,
should
right.
go to 0 for that. So yeah, anyway, so you learn by mistake only. Mistake, no problem. Okay, so now what I will say this T2. Think about T2. T2 is xy. T2 of xy is yx. So
Yes, sir.
T2 we can corresponding to a matrix. How? What is the matrix? I mean, when I say, I mean, first of all, the general thing is any linear transformation from a finite dimensional vector space to finite dimensional vector space can be represented as a matrix. Okay, and is equivalent to a matrix. Linear transformation, which is a function, that is a that is equivalent to a matrix. So how? See, you see if T2, if you know the or the basis vectors are 1 0 and 0 1, right? In R2 we can prove that 1 0 and 0 1, they are trivial. I mean, this is their standard basis of R2. So if now I evaluate at the standard basis 1 0, which will give you 0 1, and T2 of 0 1 will be 1 0, right? So I will try to write this 0 1 as a linear combination of these two bases in the same order. So what will happen then? That will be 0 times 1 0 plus 1 times 0 1, and here what we will get 1 times 1 0 plus 0 times 0 1. In this case it looks trivial, but yeah. So the matrix, what we will take, matrix will be this 0, and we'll take this 1 as 0 1, and this 1 and this 0 as 1 0. See, here it is little bit easy. We'll see for next example, then you will understand why we are talking about coefficient will be different for different problems. Here it is easy, only 0 and 1. So the matrix will be A, will be like this. And now if you say this T of x is nothing but A of x, then you are done. I mean, T2 of x is nothing but A of x or AX. I mean, T2 is nothing but A type of matrix. Means A matrix, which by means matrix representation of this linear transformation is this matrix. So people in the exam, people might ask you to find out the matrix corresponding to T2. Then you have to find this, right? So yeah, what I would say, you try to find out matrix, like corresponding matrix for this linear system. I mean, linear equation, linear transformation. Let's say T is from set of all matrices A, B, C, D, which are going to okay, 1 minute, just doing linear transformation this way. Yeah, I mean, I'll give you now a better example. I mean, better mean it will be in your assignment also. So do this, then it will be clear. Whatever I did in the last one, you will try to do it here. So T is from, let's say, R2 to R3, and T of x1 x2 is nothing but x1 minus x2 comma 2x1 and 3x1 plus 2x2. This is your assignment question only. So if you can do it, then you don't need to do again at home. Then you can solve the assignment. You have to send the assignment solutions also, right? So that's what important. So find out the matrix representation for this T. What will be the matrix corresponding to this T? So mainly when they ask for matrix representation, so try to do with respect to standard basis. The standard basis for R2, you know, right, is equal to 1 0 and 0 1, and standard basis for R3 will be 1 0 0 0 1 0 0 0 1. And the matrix for this matrix, corresponding matrix, will be 3 by 2 matrix. So first will come from this and then this. It will be 3 over 2 matrix. So find out that 3 over 2 matrix. That's your job. Try.
Sir, how to write this one in the form of using the basis, sir?
Yes, easy basic, like I did here. Try to
Okay,
do it.
okay.
Yes. Then you will understand better.
Sure, sir, I'll try. Sir, the 3 by 2 matrix is the first two elements are
Sorry?
sir, the first two elements are 1 minus 1, second row elements are 2 and 0, third row elements are 3 and 2.
Wait. 1 minus 1.
2
Then?
comma 0, 2 and 0. Second row elements are 2 0. Third row elements are 3 and 2.
Okay, so how you got it?
Mm, I took one of 0 comma 1 t of 1 comma 0. Then I
Ah,
got 1 comma 2 comma 3. Then I got 1 comma 2 comma 3. And I have written this is as a with the linear combination of the R3 basis.
Ah, okay, okay, okay. So
So
that's
when
what you have to look at story. So if the base they change the basis, then the things will also change. It will be on 2, 3 won't be coming in here if you change
yeah,
the basis. Okay, that you remember.
yes, sir.
Okay, okay, good, good, good. Then
It
fine.
changes
You, I
depends
just
on
wanted to
basis.
know. Yeah, this is correct only. This is correct. The answer is correct.
Yeah, and one more shortcut method may be whenever the base, if the basis is changing, then it may changes. But this is the basic form of the basis which you have given R2 for R square and R2 and R3. Then I can take simply the coefficients of x1, x2 as a column, first row elements of the right hand side in the transformation.
Yes.
X1 and X2 coefficients 1 and minus
If
1.
standard
X1
basis,
and
then you
X2
can do, but
coefficients.
otherwise you cannot do, right?
Yes. Yes, sir. Yes, sir. That only I said. If it is a different basis, then we cannot do that.
Yeah, we can do that, but we have to find out the exact linear combination, what of the scalar multiplication there, right?
Yes.
Yeah,
So
I mean,
this
if
the
it,
process what you need to do is
if it was given, you
transform.
can check that also 100, 010, and 00 minus 1. That will be also basis. And if you try to do it this basis, then thing will change. So things will change, and it will be.
Matrix will change. Yes, sir.
It might be the matrix will be 1 minus 1 2 0 minus 3 minus 2 most probably, right?
Yes.
So similarly,
Yes.
this it can everything can change also if you take different basis. Let's say 1 1 1 like that. This one will be also basis 1 1 0 and 1 0
Yeah,
0.
depends
This
on
will
basis. Matrix will change.
so this will be also basic. So for this it will change. Everything will change. So that's what I wanted to discuss. That these things are not depending on only the whatever result you are getting 1 2 3. Just put it 1 2 3. It is not the linear combination. The coefficient of the linear combination is coming into the picture. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. Now, yeah. Another question from your assignment, which is T from P5R. What is P5R? I told just. What is P5R? What is P4R?
1 x square x cube x 4 x power 5.
No, no, not x to the 5, x to the 4, up to x to the 4.
X power 4. Yes, sir. Up to x power 4.
So, sorry, x to the 5. Sorry, yeah, why I mean x to the 5. You are correct, you are correct. But the dimension is 6, that's what I mean.
Yeah, yes, sir. Dimension is 6.
Dimension is 6. Because it has 1 up from 1 to x to the power 5, you have in the elements, in the basis. So find out the matrix corresponding to this, or first of all, prove that it is easy to prove, right, that it is a linear transformation or no.
Yeah, yes, sir. It is linear transformation only. Because if you find the derivatives of the elements, it's going to become as a P5 will become as P4.
Yeah, true, true. But I am thinking about something because some book they say that t of 0 should be 0. Okay. Yeah. I mean,
P
I
of 1.
gave this example, right? If we are correct, this t of 0 0 should be 0, but t of some other element can be 0. This is not a problem. So this is a linear transformation. If you find t of 0 0 which is not equal to 0 0, then that will not be linear transformation. Okay, but t of some other element can be 0. Sorry for this confusion. This is the another confusion. Okay.
So this is also linear transformation, sir.
This is also linear transformation. So T of 0 should not be any other element, non-zero element. I gave you like another. I told the
Some other
another.
element. Yes.
But t of 0, 0 should not be another element. Like t of x is equal to x plus 1. Here you can say that t of 0 is not equal to 0, so that's why it is not a linear transformation. That you can say that. So here also, if you take t of 1 is also a function, right? It's the identity function. That is 0.
Yes.
That is a 0 function. But it's that despite being this, we can say that t is a linear transformation because other elements are fine. T is a linear transformation. Okay. Anyway, T is a linear transformation.
So no need to check about the remaining condition. Directly using this LRT of 0 is 0, then sorry, if T of 0 is not equals to 0, then linear transformation directly. Can we say, sir?
Not linear transformation. T of 0 not equal to 0, then not linear transformation.
Okay, okay, not linear
Ah,
transformation.
but T of 0 is
T
equal
of
to
0 is
0
0.
has to be there in the linear
Then,
transformation, but the other two properties also has to satisfy for the linear transformation. Okay.
okay, sir. Okay, sir.
Yes, yes.
Sir, you said like how to find the matrix of this.
You can find the matrix for this one also. How to find you are asking, or I mean,
No, no. First, you asked a question for this eighth question. T
yeah.
from P5 of R to P4 of R. Find
So
the matrix of
it will be easy, right? If you take T of the basis will be for P5. It will be 1 x square x cube x to 4 like that, right? X to 5. So
yes.
T of 1 will be 0. So it will be the coefficients are 0 0. All the coefficients will be 0. T of x
Okay.
will be 1. So first coefficient is 1. So you can write as 0
Will be
plus
zeros.
1 plus 0 times
1
x
plus
like
0
that.
times of x 0
T of
like
x
that.
square
Okay.
will be 2 times x plus 0 times x square like that. So the element will be
Okay.
0, the matrix will be 0 0 0 0 1 0 0 0, and it can be another
0
also 1 2 3, like 0 0 and
uh,
0 2 0 0 0 like that. It will be like this. Okay, you understand now,
okay.
right?
Yes, sir.
Yeah, if you want to find the matrix representation, it will be like this.
Okay, okay, sir.
Yeah. So you can find the dimension and rank for this matrix. That will be, I mean, the rank for the T, it will be rank for T. I mean, the dimension of image of T. And if you want to find out the nullity of T, you can find from the rank of this matrix minus the column number of this matrix, right? So that's all this thing you can do now. Whatever we did, that those are enough for this, right?
Yes, sir. Thank you, sir. Thank you very much for
No
your
problem.
valuable time.
So you were leaving now, or
Yes, sir. I am comfortable with the concept, sir.
so I think almost all the things which I thought will be teaching or is done, because you are the only fellow now. Because of that, I think we could finish it early also. And
Right, sir. Because
yeah,
more number of candidates means different type of questions they may ask.
yeah. So I think then I will also stop maybe, because although I have to do, I would have done much more.
Yes, sir.
Uh,
Thank you very much. And I think this is the first session I am attending, sir. I did not attend earlier sessions and previous courses also.
oh, why?
No, I don't know. This type of things will be interactive session will be there or not.
Oh, but you are giving exam for this
Yes, sir.
NPTEL?
Yes, sir. I am writing the exam.
Oh, okay,
I
okay,
am
okay.
attending all the assignments and doing on own.
Oh, okay, okay. So you come to this our session, then it will be easy for you. I mean, you can do better, I
Yes, sir.
think.
Yes, sir.
And we have a
Yes, yes.
YouTube channel also, right? We are giving posting these videos, recorded videos are there. So I think I should give you the link also. Wait, because when you can check it there.
Okay, sir. So other students also can, I
Yeah,
mean,
all the students there. It is the link will be there. Officially, it is there. So you can check the link and you can get it. I mean, you can find the recorded videos there. Okay.
okay, sir.
So 1 minute, I
Okay,
will
sir.
just share with you.
Sure.
Yeah, let me just open the. Check all other videos.
In that NPTEL, sir, I can say.
Hello. Did you
Yes, sir.
get Did you get the link? Can you see that whether
Yes,
all
sir.
the videos are there?
Okay, sir.
You check it out. You will see all the videos are there, and yeah, you can find all the videos there. And yeah, thank you for your attention. Check all those videos. If you have any doubt, you ask me. Okay.
Sure, sir. Thank you very much, sir.
Yeah, and join the next class also for the. I mean, you can get
Sure, sir.
you
Sure.
you find it interesting, then you join. Huh? We'll discuss
Thank
like
you.
this
Thank
in
you.
the next again Saturday on the same time.
Sure, sir. Thank you,
Okay.
sir.